Thanks, Will. So today I'm going to do a very quick run through the circular economy, but mostly focus on how I think structural engineers can have a big impact now, plus some of the key concepts that you need to be aware of. So we'll start with a definition. A circular economy is an alternative to a traditional linear economy in which we keep resources in use for as long as possible, extract the maximum value from them while in use, and then recover and regenerate products and materials at the end of each service life. So for example, we reuse a beam as a beam, we reuse a joist as a joist. So the key point to remember is to keep elements circulating in their highest value form for as long as possible. So a circular economy within the built environment is required to address the global issue of resource scarcity and environmental degradation, which basically means we need to stop the relentless extraction of virgin resources and we need to minimize our waste. It's important to note that it is often, but not always the case, that following circular economy principles will lower whole life carbon, thereby helping to address the climate emergency. These remain two different global issues that both need addressing. So the good news is that as structural engineers, we can have a huge positive impact on the dual crises facing us just by optimizing our existing resources. So this means reusing buildings, systems, components, and materials rather than recycling them. And it also means deconstructing, not demolishing existing structures. So if we just run through the hierarchy here on the right, the first priority must always be to maintain our existing building stock and retain as many buildings as possible for the future. And if this is not possible, then we work our way down the hierarchy, considering refurbishment and then repurposing via adaptation. And if the building really cannot be saved, then deconstruction and reuse needs to be considered. Demolition and recycling, i.e. business as usual at the moment, it just has to stop. We can't carry on doing what we're doing. This shouldn't be anything particularly new. Structural engineers generally work on a lot of refurbs, so we're very well placed to help clients work out how to repurpose their buildings and the materials within them. And in fact, I personally think this is the way in which the structural engineering profession will need to redefine its role as traditional new builds become less prevalent. And we're already seeing the GLA in London asking for repurposing strategies prior to granting planning for demolishing an existing building. So things are changing. And I think it's always useful to have a few examples of how you might be able to make reuse happen on your projects. And it doesn't have to be anything amazing, sci-fi like Will mentioned. One of the easiest ways is to reuse materials on your own site in a different area. So for example, you might be cutting a new floor void for a staircase or a lift and taking some structure out. So can you actually reuse that structure to trim a new void elsewhere rather than throw it in the skip? And then at the more extreme, sort of largest end of the scale is the option of completely reusing a structure from one building to construct another building. And we're actually looking at this for a couple of clients currently. And one project involves the deconstruction of an existing 1990 steel frame with 14-meter long steel beams, which we're looking to reuse to construct a new steel frame for a building which handily requires 13-meter spans. So quite exciting project. Brickwork is relatively easy to clean up and reuse if it's set in traditional lime mortar. But if it's in cement mortar, then why not cut the walls into sections and reuse in sections? And finally, if you can't reuse components for their existing function, then can they be repurposed for landscaping or street furniture? And this is an approach we're hoping to use on one of our master plan housing projects, repurposing some of the existing building precast panels as retaining walls. At the moment, reusing materials can actually be a fairly easy sell to clients, considering the material shortages that we're currently experiencing in the UK. For example, on one project, we were recently quoted 22 weeks lead-in for new imperial-sized bricks and a further 8 weeks for the slip bricks that we actually needed. So if you can actually salvage existing bricks, then this could greatly reduce your program. So how do we communicate this thinking to clients? At Elliott Woods, we're starting to produce this type of drawing, which shows existing building structures that are earmarked for demolition as part of the project. The idea is to quantify the materials that will be removed during that demolition and highlight possible alternative uses to make the client think twice about demolishing the building in the traditional way. If nothing else, it does at least start the conversation. So that it was all relevant if you've got an existing building to start with. If you happen to be in a situation where you're designing a new structure, you don't have anything existing on your site, then you need to think first and foremost about whether you can source any secondhand materials and incorporate them into your design. But there are also other things that you should be doing too. You need to make sure that you're designing your building to ensure the structure is separated from the services and the architecture, so that the building can be easily refurbished and upgraded in future. Flexibility is important, but I think the iStructe and myself were aligned in thinking that we shouldn't be designing for unknown loadings on the off chance that someone may want to increase the occupancy or change the use in the future. I think adaptability and deconstruction are probably covered best in the same way, thinking about how you can dismantle a building and avoiding glues and welds as far as possible in favour of dowelled and bolted connections. And then finally on the list there, material passports is another important factor, which we should all be thinking about. So how do we record the information about how the building is designed, the material specifications, etc. for the future? And I'll touch on this in a bit more detail in a moment. So here's an example I just wanted to show you. It's a timber pavilion building. It's a new build that we're working on, where we've managed to source materials locally and designed the building to be fully demountable. So it's got a strong sustainability story, which you can see here on the right of the sketch. Timber from ash trees locally on the estate, which are susceptible to ash dieback, and so would probably have to be cut down anyway, are being manufactured into glulam and plywood structural elements. At that point, material passports are assigned to each element to store the strength and the utilization data for reuse. And the building is then constructed using removable fixings, such as bolts and dowels wherever possible. And then at the end of the building life, the structure can be disassembled and these elements can be reused in other buildings, which establishes the circular economy. Just wanted to point out the QR codes are quite interesting. They link to a material passport, logging the items on a database, but they're also designed so that visitors to the building can scan the QR code and find out where the materials were sourced from. So I'm looking forward to seeing that one in action. So back in June, the iStructe held a panel discussion around the circular economy. And last night I had the pleasure of rewatching it all and watching myself, which was never a fun experience. This mind map was put together to represent everything that we talked about, which was my way of trying to pick out the key takeaway messages. And I'll leave you to look at it in detail in the slide pack, but wanted to highlight a few things on the next slide. So main takeaways. The circular economy and reuse in particular is the game changer to help us meet carbon targets and to address the ongoing environmental degradation we're experiencing. It's a really exciting and it provides many, many opportunities for us as structural engineers. Number two, early involvement of demolition specialists is key. If you want to deconstruct and reclaim parts of a building, then you need to engage demolition contractors early on to establish what's possible. And in fact, we'd actually recommend through the research we did with Grosvenor that the demolition specialist joins the design team as part-time consultant throughout the REBA design stages. Client backing is absolutely critical to making reuse happen on projects. A fully committed client is needed because it will probably be more difficult and time consuming than business as usual, at least for the early adopters. The intention must be set early and fed through to the client brief and all the specifications on the project. Doesn't mean you can't give it a go without a committed client, but it does help. Big point here, we cannot wait for policy. Unfortunately, current policy in the UK, particularly taxation, works against reuse. The policy is starting to change, particularly in London with the new London plan, but as an industry, we need to make this happen ourselves. It will just be too late once the government catches up. Next, tenders need to be rewritten to incentivise reuse. So demolition tenders and main contractor tenders always seem to concentrate on who's cheapest and quickest. and we need to skew or change the metric so that we can skew the right answer towards reuse. So perhaps capturing diversion from recycling rates or carbon stored in the materials that are salvaged. Next is information. So information about building construction, material specifications, and deconstruction plans must be better thought out and stored for the future. Material passports, BIM models, deconstruction sequences all have their place. And ideally, we'd have a central repository where we can all find this information when it's needed. Wouldn't that be nice? Number 7, flexible design process is needed. So the design process needs to be less linear. It needs to be more iterative, more collaborative, with non-traditional design team members invited to the table at the right point. And the design team should be more hands-on with helping to test and procure materials, at least for these first few projects until we get to a critical mass. And then finally, the overriding kind of theme from the evening in that panel discussion was that we can all drive change and we all have a role to play, and we all need a bit of a mindset shift. So one issue we discussed a lot is metrics. How do we measure the circular economy? And the truth is there is no current industry consensus on this issue, although I will run through a few examples as current suggestions. So first off, with an idealized circular economy, this is what we'd be aiming for: 0% virgin resources, 0% wastage, meaning that all of the materials are 100% reused and reusable in future. So this is clearly not achievable within the construction industry right now, but we should be starting to measure circularity and setting targets in our project briefs. So we need to measure circularity for both the inputs to the circle and the outputs from the circle, which, like I said, will ideally drop to 0 in time. So in terms of inputs, we can track the percentage of virgin materials used in our projects and the percentage of elements that are reused. We could also look at recycled inputs as well. And then at the output side, we should measure the percentage of elements that are expected to be reusable in future, so those that are designed for deconstruction and salvage. And we can also look at percentage waste diverted from recycling, from current recycling routes. Another way of looking at the impact of circularity is to consider the impact on life cycle carbon. For a new building design now that uses virgin materials but is designed for deconstruction, the benefit in carbon terms will be realised in module D. And this is the potential benefit of the building to future projects. It can make it quite a difficult sell because there's no benefit currently realised within life cycle modules A to C. So here you can see this indicatively by comparing a typical new build on the left with the same new build designed for deconstruction in the centre. The design for deconstruction chart shows a much larger module D. The negative is good for module D, as it indicates greater benefit for future projects or lower carbon emissions in future. So the main carbon benefit is realised here on the right when you start to reuse materials as shown on the right-hand chart. Here, the A1 to A3 module has reduced significantly by reusing those materials. Obviously, the extent to which this reduces will be dependent on the quantity and the type of the materials reused, but there should be a significant saving in upfront carbon. A4 transportation may also reduce depending on your project specifics, but A5 and C, I've assumed, won't change much. And then on the basis that you'd also design that building for deconstruction still, module D remains the same as the design for deconstruction case in the centre. So now we have some way of measuring circularity, albeit not perfectly. We should be ensuring our clients include relevant metrics in their briefs and specifications. What values are appropriate? We're working on some projects where we're aiming for 25% or even 50% reuse for a specific material that we might be targeting on a project. We need to be absolutely clear that reuse means reuse and not downcycling. So for instance, crushing of concrete for hardcore is not reuse, it's downcycling. And if we can't do it for the whole building or a large area, then we should aim to make something happen within a small exemplar part of the building. So just a quick look to the future. In the future, I'd love to be able to pop down to my local builders merchants and have the choice of buying secondhand materials alongside new. Ideally, all the structural materials will be graded and tested and be sold with certification. and reuse of materials will become the norm within the construction industry. And then finally, a bit of a rallying cry. If we all take a small step towards this on each of our projects, then collectively we'll start to have a huge impact. And I believe that's about 15 minutes. Thank you.
I hope the attendees can tell that I was very demanding with the time requirements on people today. Thank you all so much for sticking the time. Thank you, Penny. That was I really like the phrase reuse a beam as a beam. That's going to replace calls a spade, as far as I'm concerned, in terms of describing things eloquently. I also think, you know, you made the point about the sort of relevance of this topic right now, where we're in the middle of so many material shortages, and particularly here in the UK, although it's, you know, wider than just the UK, and you can't help but wonder how much more common that's going to be in coming years. So yeah, if ever there was a time to try and get your head around the circular economy, this was definitely it.
Yeah, definitely.
Okay. I'm going to hand over final speaker of the day is Mike Sefton. So Mike is I'm going to hopefully get this right, associate innovation engineer, I believe that's right, but used to be a practicing structural engineer as well before he started doing too many weird and funky things at Expedition. Mike, his name came up right at the start of today when I put a couple of pieces up on screen, one of which was to do with the future R&D needs of the profession. So really trying to look at closing that gap between what we can do with what we have available today and what we need to be able to do in the future. So I'm hoping he's going to give us a few insights into some of his thinking around the topic of where we need to go as a profession in coming years. I'm really excited to hear from you, Mike. Over to you.
Super. Well, thank you for the intro, Will. And thank you for everyone listening in today. The title of my talk today is quite a broad title and could cover almost anything, I guess. But I want to use it as an opportunity to talk about two topics which are quite different, but I'm equally passionate about. In the first of these, I want to look towards the future and what palette of systems, tools and materials that we as structural engineers and the construction industry need available for us to keep driving our greenhouse gas emissions down when the current approaches that we've been talking about today and other times reach their limits. But the most important thing from this is to identify what we need to do now to make sure that they're in place at the right time. And then in the second part of my talk, I want to look at the extra value we can bring to our work right now, or in many ways put as simply as I can, how can we do as much good as possible? And also argue that considering our current negative impact on the environment, we have a duty to do as much as we can. So jumping into the first topic, what do we need to do now to prepare the construction industry for future carbon emissions reductions? And how can we positively enable critical and successful research to develop through to market-wide use in time? So, as Will mentioned earlier on, this is based on a paper that he and Pete Winslow and myself wrote for or an article really for the structural engineer earlier in the year. And it came about through conversations with people across the industry, where we compiled a wide range of real development needs that we feel are important to keep driving future emissions down. But I guess, start at the beginning. What do I mean when I talk about being able to keep reducing emissions in the future? Well, we know that we need to reduce global emissions right now and then stay in line with the IPCC pathway to keep below a 1.5 degree temperature rise. And rightly so, much of our thoughts are on the drive to change things right now and actually push that curve going downwards rather than carrying flat. But largely this is going to use changing best practice, using all the tools, technology and materials we have available to us right now. And it's critical, but at some point we're going to hit the buffers of what is viable through these current approaches. So I guess what I'm thinking about when I talk about now is we don't want a pathway for our industry that starts going down nicely now, but then levels out like the red line on this chart. We want one where we keep going down to 2040 and through to 2050 and hit zero. I guess thinking about that in project terms, in the immediate years, we have all the tools to deliver projects that could be described as green and having a little less negative impact or doing our fair share. But actually, how are we going to get right down to all of our projects being sustainable or even moving better to being restorative and regenerative? So the thinking in the paper is based on a belief that it would be possible to exceed the 45% carbon reductions required by the IPCC pathway by 2030 with an industry-wide move to current best practice, using all the stuff that's been talked about today. Yes, refurb first, design efficiency, maximization of utilization, specification of currently available lower carbon materials, and more. And that sort of gave us a 2030 horizon to look at. But I think some of the conversations that have been going on earlier on day one suggest that potentially legislation could come in and drive that sooner. So we're not looking at a large or a long timeline in terms of bringing some fresh and new technology through to widespread use. So I guess I want to use one example that we've been looking at and then go out to a bigger, wider picture. So we've been looking at concrete, I guess, as a material. And with work that Expedition have been doing on Network Rail, we've been in a position to think about that a bit more in depth than many people would do, I guess. And so we produced, generated a chart which looks through the next 30 years on how concrete as a material might reduce its emissions. And I guess the first thing on the chart are all of the things that we can do now. So we talked about reducing the volume of concrete and rebar used. Paul talked about that earlier on, and use of efficient and optimized existing Portland cement concretes, and also use of efficient optimized steel reinforcement. So all of the minimization stuff that we can do today can take a large chunk off of the embodied carbon used in the concrete we use. But we hit a point where we've maximized all that we can out of that. So again, as sort of Paul mentioned earlier today, we know that a large part of that embodied carbon lies in the Portland cement content. And at the current time, one of the best ways of driving that material carbon down is through GGBS and fly ash substitution, but that these aren't available in as large quantities as we might need, and that they might reduce in the future. So it's felt we need to look towards potential alternative, novel and next generation cements. And these may be currently available, sort of alkaline activated cementitious materials, or maybe next generation cements involving calcine clays. And some of these may be in low volume use already, and some of which are at research stage. However, if as an industry, we want to rely on those in 8 years' time, we need to start looking for routes to increase their use in a manner which manages the risk of using these less familiar materials. It requires testing and piloting and potentially developments in code and calculation approaches to ensure that the development of these new products is effectively managed. So in the chart, these are shown to be starting to be used now with increasing use in the future. But to have the best chance of this being a successful development, I think it requires a collaborative market-wide approach so that potential opportunities don't get lost on the way, and so that a wide enough spread of research and trialing can be carried out to give the best chance of success for the whole of the industry. And sometimes this might be needed to overcome, I guess, commercial drivers which aren't currently in place in the market, but maybe later, maybe we're too late by then. I think beyond this as well, pragmatically, there has to be some carbon capture and use or storage, but we need to be in a position to say we've done everything possible to reduce emissions before we start relying on that to be a technology in place to mop up just the last few bits, really. So I've used novel cement development as one example that we're thinking about. And the intention is to see if we can promote a coordinated cross-industry effort. But we believe that the industry needs a systematic review of all the activities that go into design and construction with a long-term view, because we won't be able to truly minimize emissions if we have any weak links on the way. In our paper, we categorized our thoughts into 3 themes: design and process, materials, and construction maintenance and deconstruction. And through our discussions, we identified a number of challenge areas within each of these themes. So under the design and process theme, we considered how the industry can transform normal building typologies to a new reduced carbon standard. and how we can begin to balance the use of different materials across our industry to best effect. How we can effectively balance a circular economy, such as Penny has been talking about, and how that the design can respond in real time to available pre-used materials. How we can implement decision-making tools and improve calculations to automatically minimize embodied carbon and incorporate off-site construction to best effect. In the materials theme, we considered natural materials may benefit from co-developments and development of a healthy supply chain to enable greater uptake for uses where they're beneficial, and how the materials in more common widespread use currently, such as steel and concrete and brick, can be made as low carbon as possible and used in areas where their properties are most essential. In the construction, maintenance and deconstruction theme, we considered the elimination of on-site and transport emissions, but also the real risk of the performance gap between emissions calculated during design and those really emitted in construction, in similar fashion to Julia was talking about earlier as well. And often, for example, how can we minimize the use of more materials than are on the drawings or unexpected waste streams, and design for this in the first place? We also looked at what we might need to consider for maintenance and refurbishment at lowest carbon value, and how deconstruction can link effectively into a circular economy using materials at their highest value. We don't have time to dump into each one of these, but the aim of the paper is to initially sort of get a list together to trigger debate in the industry. Research, testing, and piloting is happening in all of these areas, but our hope is that the industry can come together and drive a unified agenda to really focus on and support the research in areas which can help us with a truly sustainable future. And that the industry can establish pathways to take the research through to widespread use with the best chance of success. As engineers, we have the opportunity to become more involved with this type of development, to shape what we feel will be important in our industry and advocate for its development and champion piloting and working with new approaches on our projects. If we don't, there is potential that a decade of truly great action now could fade just at the point where we really need to kick on. So I've been talking about opportunities in R&D to ensure we can keep on a downward trajectory towards a zero carbon future, but implicit in this statement is that we have a period of time where we will continue to harm the environment with the work we do. As we work on green projects, we will be reducing that level of harm, but still we will be responsible for carbon emissions into the environment through the majority of our projects. So in the second part of my talk, I want to look at maximising the good that we can do through our work, maximising the positives out of the harm to the planet. The idea of doing good in our work is a fairly loose and subjective term. However, we have ways of defining outcomes, so I want to spend a few slides talking a bit about this. At an economic level, Kate Raworth's donut economics provides the concept of balancing a world where we operate within our planetary boundaries, whilst ensuring we provide a social foundation. And it's this social foundation I'm thinking of when I talk about doing good. But how can we be clear about our work and projects and how our projects contribute to the world's social foundation? We can look to the United Nations Sustainability Goals, and they can help us drill down and separate this out a bit further. And we can use them to look at social, economic, and biosphere impacts and look at the good work that our projects and their outcomes can have. But also we can look at the way in which our companies operate and how the way we treat our employees and our recruitment can also have an impact on these goals. So I'd advocate actively considering which of the UN SDGs your work and projects impact on, and look for opportunities which increase that impact. However, a recent report by the ICE in Useful Projects called Maximising Social Value from Infrastructure Projects identified that there are real missed opportunities to create social value in the planning and design phases of projects, due to the focus of these mainly being during procurement and construction phases. This suggests that we could really have more of a focus on social value during design work. And I know this is something that's often outside of a structural engineer's remit, but just by having conversations with people about this sort of topic, we can really bring it to the forefront of people's minds. At a project level, the Construction Innovation Hub have developed a method of creating a value profile during design and development. This looks beyond the typical measures of value of cost and program, and it includes the the human and social impact of a project, and also the natural value too. The value toolkit, I understand, is coming to an end of the test period this month, so hopefully it'll be fully launched soon and a wider picture of value could become an industry norm. Ultimately, we should stay minded, though, that where our designs have a negative impact on the environment, we should really consider why is a project needed and who will it affect and who can it benefit more, rather than just jump straight into what is the solution and how will it be built. And it's not just through the projects we create where we can maximize positive social impact. It's also the way we do our work, the way we procure our projects can benefit social enterprises, local startups, or small and medium-sized enterprises. And we can ensure that there is an ethical supply chain in place. We can also focus on nurturing our own staff and supporting young talent to enter engineering from diverse backgrounds, and look to how we can help our area through local community projects. I just want to conclude my talk with a mention towards nature. As an industry, we're getting to grips with our emissions impact on global warming, and we've had a whole conference about it now. But I strongly believe we have significantly less awareness of our direct impact on biodiversity in the natural world. I feel this is a harder topic for us to consider as structural engineers, but we need to move it up our agenda. This year, the United Nations has declared a decade of ecosystem restoration. There have been significant publications, both internationally and in the UK, such as the Structe report on the economics of biodiversity, which outline the challenge to shift our global economy to one which values nature kept in its place, rather than just monetizing its extraction and use. As we look to improve our work, we need to become more aware of the impact on nature of the materials we specify and the effects of their extraction and processing. We need to think more about the site activity that our construction demands and the permanent change that our projects make on local ecosystems. So I'd just like to conclude, looking back briefly, I'd ask you to consider where you can find ways to contribute towards the development of innovations which could help us continue to drive down emissions in the future, and also to have how you can consider doing more good through your projects to society and to nature. Thank you very much.
Thank you, Mike, and thank you for sort of broadening the topic out so much wider than just carbon for us. Really interesting to hear your insights on all of that. We've got a bit of time left for a bit of Q&A to both Penny and Mike, so as always, continue to put your questions in the chat. We've had quite a lot through already, so I'm going to just kick off straight away with Penny, if that's okay. And the question that first caught my eye was around the risk around reusing materials. And I think the question was, who does the risk lie with? But do you have any sort of broader comments on risk of reused materials and maybe what to do about it?
Yeah, I mean, this comes up every time we talk about reuse. It's usually one of the client's first questions. And I think I answered this question actually in the panel discussion. And I suppose take a step back. How often do we refurbish existing buildings where we might test some of the steelwork in that building, for instance, but we by no means test all of the steelwork in that building? Maybe it's a grade 1, grade 2 listed building, and no one really asks that question. But as soon as you take that steel beam out or steel column out of a building, it becomes a risky situation. And I would always argue that if you're going to test those materials, you know what those materials are. If you've taken it out of the building, you can see all of the elements. So I actually don't think it's as big a risk as everyone is saying. So I mean that would be my starting point. But obviously that's not always good enough for clients. I would say that as structural engineers, we would retain design liability for designing a building using reused materials in the same way that we would for a refurbishment. But that would obviously be based on testing and knowing what those materials are and designing appropriately. We would be looking to a third party, such as a fabricator in the case of steel, to provide a latent material defect warranty or certification to prove that the steel is what they say it is, essentially. And the research that's been undertaken with UK GBC around this, and with a guy called Roy Fishwick, who works for Cleveland Steel and Tubes, who's really pushing steel reuse and is a steel person. And that research has shown that there's no issue with insuring these buildings. So, I mean, that's quite a steel-centric answer, but it's the easiest to kind of explain.
And that sort of resonance, you know, testing to prove what you've got is the first obvious step, right? And then I think you're right. I think you can consider it, well, it hasn't, you know, how different a position are you then actually into when it was new. There was an interesting paper, I know, a guy called Michael Juniak wrote us a paper a while back. Again, it was steel-based, but I think, again, the sort of, you know, topic he was talking about is why the steel. And he made the point that actually a lot of the sort of barriers to circular economy thinking are just perceived barriers rather than real ones. And as soon as you start digging into them on a project with a client, you can quite quickly realize where the actual difficulties lie versus the things that you just need to do a bit of testing or get a few things written out on paper for.
Yeah, exactly.
We also had a question. So somebody firstly said that, you know, really resonated. What you said really resonated with her when you made the point about not designing for an unknown future, but instead just to sort of design to be more circular. Do you have any reflections on, you know, sort of adaptability versus over design, say within that context?
Well, I was speaking at a REBA conference on this last week, and I think at the moment, given the crises that we're facing globally and the climate emergency, we need to be concentrating on reducing our carbon now, and that's kind of the message that the institution is sending. So we design for the known use case now, and make it as easy as possible to adapt that building in the future. And that just comes back to all the things that I mentioned on the slide. So designing in layers so that you haven't got services intertwined with structure, you know, going through it left, right, and center, maybe fixed to structure in the way that we might have done in the past. But thinking about, right, well, this M&E system is going to have to be replaced in 25 years' time, whereas the structure should be good for at least 50, 60 years at minimum. And so how can we design it so that someone can come in and upgrade the M&E services or upgrade the facade without having a negative impact on the structure? And I think the same thing goes for adaptability in terms of maybe adding stories or doing lateral extensions to buildings, is thinking like, how can you get access through finishes without negatively impacting the structure below, so that you can make it as easy as possible to bolt onto that existing structure, for instance, to do an extension or a rooftop extension and so on. So I think it's more about how these parts of the building are designed and thinking about it in a slightly different mindset, not just about how is it going to go up, but how is it going to come down and how can it be changed in the future.
Yeah, thank you. Fantastic answer. Mike, how does all this tie in with what you were, I mean, you kind of only really touched on this at the end in your slides, biodiversity, but I know it's something that you've thought a lot about in recent months. How does the conversation around circular design, designing for reuse, but also reusing what we already have, how does that tie in with your own thoughts around biodiversity?
I think that reuse just has to be such a significant and important part of it, because as soon as we're extracting material from the planet to use, we're not in a good place. And so the reuse can just minimizes that straight away. And we're not going to stop extracting materials, I guess, but the more we can reuse of what we already have, then the less we are going to be doing that. And so it sort of minimizes the thoughts you have to have straight away on where you're getting your materials from, because you know where it is and you know that you're doing significantly less harm by reusing what we've already got.
Yeah, no, absolutely. That makes a lot of sense. Do you think well, okay, so we've had a question, should structural engineers learn more about systems thinking and nature connection? I imagine your answer to that will be quite short. But maybe if you get a sort of just tie into what you were just saying as well, yeah, what can engineers do to learn more about these sort of impacts and this link back to biodiversity and how their work impacts on biodiversity? Where would you suggest people started with stuff like that?
At the moment, I think that's a really challenging question, because I've struggled to do that as well myself, and I feel like I'm giving it quite a bit of thought. There are, the disciplines within our industry who know about site ecosystems and managing, kind of positive impact on nature locally. But there's less when you start looking at material supply chains and origins of materials. So at the minute, I think it's a very difficult topic to get into and know what is best practice and what isn't, which is why I really think it's something we need to move up our agenda, because I don't think the answers are out there. And in the way that carbon counting has become something that everyone can grab now, and it has a metric and we can use it, and it's a change in practice, but we can sort of see the road to it, the way through it. I think we need to start thinking similar things on nature and biodiversity and impact on the planet that way as well. But it does feel like we're quite a long way off that at the moment.
Yeah, I agree. It feels like a research need for sure, or at least for somebody to try and take that existing information in the right people's heads and get it condensed down into something understandable by a structural engineer, sort of relevant. I think there is a bit of a gap there, isn't there? I think we've probably only got time for one more, really. Penny, there was a question around if you're reusing material. Well, there's kind of two that go together, I guess. So why don't I try and squeeze them both in? One around reusing materials and how much it reduces A1 to A3 emissions by, and then there's a second one that's if you're retreating materials, say, I don't know, recoating steel, for example, or reimpregnating timber, how do you consider that within the A1 to 3 emissions of that new building that you're reusing them for?
Yeah, it's a good question. I think obviously the A1 to A3 emissions of a reused piece of material, reused element, are not zero, because it's very unlikely that you would be able to take a steel beam out of a building or a piece of timber out of a building and not do anything to it. But they're quite minimal, because A1 to A3 covers the product stage of embodied carbon. So it's taking the raw materials out of the ground and turning it into a product which is suitable for construction up to the point at which it leaves the factory. So obviously you're not having to do all of that to an existing element, but there is a degree of sort of refabrication of steelwork, for instance, repainting, cleaning it back. Same with timber, cleaning it back, maybe changing the size of it slightly, reimpregnating it with whatever treatments it requires. So I'm not 100% sure that there is actually defined data out there at the moment for those processes. I think what we need to do is dig down into some of the EPDs that exist for the virgin materials, and try and take a proportion of those for the relevant practices. So it's sort of on my list of something to dig into a bit more with some of those suppliers. Yeah, well, that's the plan, to try and sort it out. But I would guesstimate that those emissions are going to be 10%, 15% of a virgin material, and I think that's probably a reasonable rule of thumb at the moment. Yeah,
that'll be interesting to see what you find. It feels like the sort of answer that's not too far off being attained. It just takes a little bit of time for somebody to dig and ask a few questions. And I would say that if you're working on a project and you are seriously considering reusing things, to then speak to contractors about what recoating is going to need to happen to this, what retreating will need to happen to this. If you get the right person, you probably can start to sort that out on a sort of case by case basis, I would have thought. Yeah, and it will vary, won't it, from element to element, but you can't get too prescriptive about these things. And like we've always said with the structural carbon tool, it is plus or minus a good 5%, if not 10% on these numbers anyway. So I think if we're taking an average for refurbishing that piece of material, then that's probably close enough. It's still going to be significantly less, which is the main point. Yeah, I agree. Look, thank you, Penny and Mike. I won't keep you any longer. And obviously, we've still got 100 or so people listening who are probably all waiting to go off and finish their working day. I just wanted to put some closing thoughts up at the end, because as with day one, it's been actually quite a lot of sort of repeating messages as we've gone through the different talks. The first thoughts were, there's nuances around steel, concrete, and timber. They've got completely different nuances. They've got some overlap, but it's worth understanding them. It helps you answer tricky questions that you get from architects and from clients. But then the one thing that seems to completely tie them all together is just about using less of all of them as being the biggest starting point, and going back to structural efficiency as a driver. Never been a better opportunity to be able to tell an architect to put those columns close together, I'd suggest. What gets built is as important as what gets designed. That came up at least more than twice. And actually trying to speak to your contractor to work out what it is that's going to get built. I'd say this is a really important part, because what you design is not what's going to go into the atmosphere. What you design just indicates what needs to happen next, and making sure that that really does stay within the sort of the assumptions that you've made at the start around carbon really is important if we're going to see this through. Think holistically, we've heard again and again, wider collaboration. So no more on that. A beam is reused as a beam is still my favorite thing that's been said over the 2 days. And I think keep pushing is something that's come up again and again, right from the very first talk we had at the start on policy, right the way through to Mike's talk at the end on the future of the engineer. The need to just keep driving in these questions, putting the questions to clients again and again, asking the architects why not, asking the contractors why not, and safe in the knowledge that we will make progress if we keep it up. And hopefully that's sufficiently buoyed you on to not give up when you get into work tomorrow. The last couple of things I'll just share before we go. So the Design for Zero guide, I think I mentioned this last time as well. This is coming out in the next few weeks. You can pre-order a copy online, but I just sort of put it back up because there's a lot of what's talked about in Design for Zero is on the same sorts of topics we've talked about today. So how do you go about reusing things? What are good examples of projects where you've actually built less or built nothing at all that you can then show off to clients to help them understand that these are not just theoretical ambitions, but are very doable. So do check the guide out when it comes out. Draw your attention as well to the on-demand e-learning course we're doing around embodied carbon basics. This will go live in the next month or two, hopefully. Completely free for our Strut team members. You'll be able to watch a series of videos that will take you through some of those material nuances again, and give you some sort of quizzes to check your understanding at the end of them. And we'll also cover, what you do with your results and how you apply carbon calculations to reuse and all that kind of stuff. It should give you a really solid base of understanding. And if you already think you know it all, I might even suggest it's worth doing this as a refresher, just fill in some of the gaps. And then you also see on the screen Net Zero Structural Design, which is a course we're going to launch in 2022. So sign-ups for that should be going live fairly soon. So keep your eyes peeled for that, and that will go into a lot more depth than the basics course. Final plug before I go: there is a SME Business Practice Conference coming in a couple of weeks' time. So if you do work for a small practice, do come along. It's not a sustainability conference, but there will be a sustainability slot in the middle of it. It's a really good opportunity for you to learn from other sole practitioners and small to medium-sized practices, beyond just sustainability. But do come and join us for the middle bit, if nothing else. And there is a discount code on the screen, CEC. It's not particularly hard to remember, hopefully. That's it. Thank you to all of our amazing presenters across the 2 days. Really, really broad range of expertise that they've all brought to this. And I hope that you've enjoyed listening, for those of you who joined us for both. Don't forget, you can get the videos online. Hopefully they'll be up there soon enough. Just watch this space, keep an eye out on social media. I'm sure we'll post some links when they go live. And except for that, I hope you enjoy your evening, afternoon, morning, depending on where you're based. And stay in touch if you want to get involved further on any of these topics. Thank you.